This is the second video in which I compare Delta44 with a Maya44 running on the output of an IQ Plus. And you can see the operating system is Windows 10. Look at the previous video for setup and the calibration procedure. I will show a little bit more about calibration and also performance. The S-meter graph is calibrated to show the signal level that I have measured to be present on the antenna connectors of the IQ Plus. That's minus 22 dBm, and you can see that's what the evaluation says here on both systems. The signal level is a few tenths of a decibel below the point of saturation. When I switch off the signal generator like that, then we get the noise floor. And the bandwidth is set to 10 kilohertz. You can see that I grab the BFO and move it to one side here, and you can read 144110, and at the other edge you have 144.120, means 40 kilohertz. Sorry, means 10 kilohertz and 40 decibels. The noise floor is, we can see here, minus 123 dBm in 10 kilohertz. That's minus 163 dBm per hertz, and that's 11 dB above room temperature, which is minus 174 dBm per hertz. So the noise figure with the Delta44 is 11 dB, 15 kilohertz from the center. The Maya44, the noise floor is minus 118.5 or minus 119.5. Let's say it's minus 119 on the average. That is minus 159, and that is 15 decibels above room temperature. So noise figure 15 dB. If I step up to 120 here and here, and then wait for a while for the new value to come on the S-meter graph, the noise floor on the Delta44 is minus 123.5, and on the Maya it is minus, well, it didn't change noticeably. So this is the situation we had. Now I will connect the pulse generator that was used during calibration. And that gives a lot of interference. The level is minus 82. And that is, well, where did we have the noise floor? It's minus 120. So it is something like 45 or 45 decibels of interference. 45 decibels. That's a lot. I switch on the noise blanker by clicking the smart blanker here on the Delta44, and I click the smart blanker on the Maya44. The Maya44 doesn't work at all, means it happened to start in the wrong time shift between channels, I have to exit and then go back. Once more. Now it works. And I have to enable the S meter again. I'm at 120, so I go for the same frequency. And you can see that the noise floor is lower with the Delta44 by 5 dB. It's very close to the difference we have in noise figure. I now disconnect the interference source. And as you can see, it makes nearly no difference in the waterfall or in the baseband or in the S meter. But it makes a huge difference on the main spectrum. Those is it 40 dB or something, 45. So now Linrad is well calibrated, and the interesting thing is I haven't made any addition to the calibration compared to what I showed in the previous video. It's only the calibration procedures A and B. The other two are not used. They will degrade the blanker performance significantly. What I have done is to change one parameter in the blanker algorithm to subtract a wider range of points on the pulses. That's was the explanation why there was some peculiar phenomenon that I pointed to in the last part of that video. There is a recommendation from the IARU saying that minus 93 dBm should be S9. So I have set minus 93 dBm to the two inputs, and now the two outputs are at minus 93 according to the Linrad S meter scale. So I change from showing dBm to show S units, and I want this to be S9, so it is 4.5 unit, and I don't remember whether it's decibels or S units. Probably it's decibels. So 6 times 4.5, that's 40. And the wrong sign, so I make it minus 40. Minus 30. Minus 27. This is good enough. I forgot I already had. No, I make it S units and minus 27. So now the S meter shows S9 on this signal. I switch the signal off, and the noise floor is S4 or S4.5, depending on which sound card, but this is with a 10 kilohertz bandwidth. So for normal bandwidth, let's say single sideband, it would be 2.5 kilohertz, something like that. The noise floor is at S3, and in the Maya44 on SSB bandwidth, like that, the noise floor is S3.5. And of course, that's because the noise figure, is about 2 S units, about 12 dB as an average between the two. So with a good LNA that didn't add any noise at all, but would amplify by those 12 dB, the noise floor would be at S1, which would be the IARU recommendation. Now, that recommendation doesn't make sense at all, of course. You add the LNA, which adds some noise, and the noise floor would go up from S3 to about S5 or S6, because you want the noise from the LNA to dominate completely. So that means listen to the quiet sky and set the S meter to show S1 on the noise floor at SSB bandwidth. That's how to calibrate the S meter, in my opinion. This is the noise floor with the blanker and the pulse generator. I disconnect it, and you see the noise floor stays the same, more or less, as it was before. The S9 signal here doesn't cause any problem. If I listen a little bit to the side of it, here and here, and switch it off and switch it on, not much happens. If I bring up the level by 10 decibels and another 10 decibels, now we are 20 decibels above S9, and there is a significant degradation. We lost 1 S unit. So I disconnect the pulse generator, and we still lost equally much. It's the signal generator, or maybe it's the phase noise from the IQ Plus, I don't remember. So this was about the noise blanker.